All right, we are officially recording. So, do you guys have any questions for me?
On the very first review,
Okay.
can we do 25?
Okay, so let me pull that up here. Wow. I was so excited that I emptied out my email box and now I've got 2 more emails. How'd that happen? All right. Why can't I find the reviews? Here we go. Exam reviews. Let me share my screen. Okay, so the review 2.1 to 2.8. And you said it was problem number 25?
Yeah.
25. Is f of -5 positive or negative? So what do you guys think? How do you figure it out?
It's positive.
Positive? How?
So you're plugging -5 into the function, so -5 is x.
Yes, so here's -5, and you can see that your y is positive. It's that point right there, just like Michael said. Okay.
So you plug -5 into x?
Well, there's not an equation to check it into, but yeah, so this is your x-axis here, this is your y-axis here. Right. So where x is -5, right there, y is approximately 3. It's positive 3.
Okay.
Okay. What else do you guys have?
Can we go over the questions about even versus odd? It's like 28 through 33. We don't need to do them all, just explain them.
Okay, so the graph of a function is given, decide whether it's even, odd, or neither. So do you want to do 27?
Sure.
27, even, odd, or neither?
Even.
Even because?
It's symmetrical about the y-axis.
Exactly. Okay. So it's even because it's even functions are always symmetric about the y-axis. What are odd functions symmetric about?
The y equals x line.
Not necessarily.
The x-axis?
Not the x-axis.
The origin.
The origin. So odd functions are symmetric about the origin. So 28, is that one symmetric about the origin?
No.
No. Is it symmetric about the y?
I thought yes when I did the review, but the answer was no.
Correct. It's neither in this case, right? 28 is neither.
So why isn't it? Because if you were to fold it in half, because it would have to be the same shape on both sides.
Well, it's remember, odd is symmetric about the origin. If this was moved up 2 units to the origin, yes, it would be odd. But remember, it's symmetric about the origin, not about the and since it's moved down 2, it's not symmetric, period, about the origin.
It's not symmetric about the y either?
It's not symmetric about the y, because if it was symmetric about the y, it would have to either go back up like this or down like this. So it's neither. How about 29? That one is odd. Okay. All right, and then we say determine it algebraically. Do you have a question about those, Lauren, or are you good on those?
Yeah, I would say I'm more confused on these.
On these, okay. So how would we do this first one?
Are you supposed to graph them?
Well, you could graph it. That would be one way, but it says to do it algebraically, and so graphing's out of the choices because we're saying algebraically. Do you remember the definitions of odd and even?
Yeah, like that one of them has a negative x instead of a regular x, I think.
Okay, so even and odd. What are the definitions of even and odd?
On an even function, f of x should equal f of negative x.
F of x equals f of negative x. Whoops, that's negative x. Okay, and odd?
Negative f of x equals f of negative x.
Oh, I should have done that one first. F of negative x equals negative f of x. Okay, so those are your two definitions. Okay. Now, let's take this first one here. F of x. Okay. If you were to guess, oh, that looks like, anyway, that's x to the third power. If you were to guess if this was even or odd, which one would you guess first?
Odd.
Yeah, probably odd because you're looking at the exponent. So what would be f of negative x in this case?
It would be, would you write it as like -1 parentheses negative 5x to the third and then distribute that?
Okay, you just told me negative f of x.
Oh, are we testing out? Yeah.
So
For
you
all.
said put a negative in front of the whole thing, -1 times negative 5x to the third.
Is that right?
So as we simplify this, that is correct for negative f of x. So the negatives are going to cancel and I'm going to be left with 5x to the third, right? Okay. So negative f of x equals 5x to the third. What is f of minus x?
Negative 5 times negative x cubed, but negative x cubed is the same thing as it's gonna stay negative because it's an odd power, and so you can have 5x counter the negative x, so it's 5x to the third.
Okay. Does that make sense, Lauren?
Kind of, yeah.
Okay. So does this number, or does this function equal that function?
Yeah.
Yes. So is it odd?
Yes.
Yes, it is. It's odd. So if it's odd, there's no reason to check even. If it's even, there's no reason to check odd. Now, let me ask you this question. This is a trick question. If I had x squared plus y squared equals 1, we're going to make this simple. First question is it a function?
No.
No.
No, because
You have a y
Yeah,
squared
circle.
and an x squared.
Say that again.
You have an x squared and a y squared.
X squared and a y squared. What does it look like
So
if you were to graph it?
An ellipse.
An ellipse? It's a special ellipse that has a special name.
A circle.
Circle. It's an ellipse that looks like a circle. And so your foci are at the center. But yes, so is it a function? So it's not a function because a circle fails the vertical line test. Now, if you were to ignore this for a moment, this is one case where if you put an f of minus x and minus f of x, you would say, oh, it's actually they're equal. It's both odd and even, but it is both odd and even, but it's not a function. And when we're talking about these, they have to be functions. And this is not a function. Anyway, sorry. All right. So anyway, that probably confused y'all. But the next question is, Lauren, do you feel comfortable? Do you want to do another one of these, or are you still uncomfortable?
I think I understand it now.
Okay. All right. What other questions do you guys have?
Number 14. On review one.
Number 14 on this one? What you said, Andrew?
Yes.
Okay. Number 14 says find the domain of this function. It's funny because it doesn't even have it in functional notation. But whatever, we'll do it our own way. We're going to say that f of x equals f of x equals x divided by x minus 5. Okay. So remind me again, what does domain mean?
Oh, that's the square root of x minus 5.
Was it a square root? Oh, I didn't notice the square root. You're right. I'm glad you noticed that because I didn't notice it and it didn't copy. Square root of x minus 5. Okay, that's better. Okay. So Andrew, do you got any ideas?
Wasn't it all? It's the horizontal. That's what I could think of. It's from left to right. Numbers on the x-axis.
You said the numbers from left to right on the x-axis?
Yeah, it's just all whatever numbers are on.
Are you saying the domain is all real numbers?
Yeah.
That is incorrect.
Like the domain for the function,
What'd you say?
or just the domain in general?
So let's go with what is the definition of the domain?
A value you can plug into the function, I guess.
Yeah, all possible x values. What are all the possible x values I can plug into here?
Well, you know the denominator can't end up being 0 because you can't divide by 0.
Okay, so the denominator cannot equal 0. Okay, that's one rule.
You also
So-
can't square root a negative number.
Can't take square root of negative number. Okay. So it's the denominator we're most concerned about because the square happens to be in the denominator. So the denominator can't be 0 and it has to be positive, essentially. Right? So how could we write that as all possible x values?
X is greater than 5.
X minus 5 must be greater than 5, right? Can it equal 5? Can I change this to x minus 5 can be greater than or equal to 5? Can I do that?
No,
No,
because then it would equal 0.
because that would equal 0. So, okay, so it's got to be strictly greater than 5. So therefore,
Would you add the 5 and then say x has to be greater than 10?
that's right, x has to be greater than 10. Okay?
No, it's x has to be greater than 5, though. Because you can plug in 6 and it will work.
Oh, let's think about this. Oh, you're right. So, yeah, you're right. You're right. So x, yeah, let's do that again. X has to be strictly greater than 5, right? Because 6 will work, 4 will not work. Okay? Can you write that in interval notation?
So that would be like 5 with a parenthesis, comma, infinity with a parenthesis.
Okay, and what did you forget?
Oh, right, x is an element of.
X, and I can't make that weird looking E. X is an element of, and then you said parenthesis 5, comma, what did you say?
Infinity,
Infinity.
parenthesis.
Okay. So X with that weird looking E, 5 to infinity. Okay. Does that make sense, Andrew?
Yes.
Okay. Okay, what else you guys got?
Can we do 37?
Did you say 37?
Yeah.
37. Find the domain of this function. Oh, that one sounds funky. Okay. What do you think?
I'm just confused at how we would go about it. Like, am I finding the domain of f of x equals 1, the x and square root of x? I don't quite know what it's asking with the information it's giving me.
So, yes. So here, this is really what you need to pay attention to, this column. Okay. So remember, domain means all of the possible x values. So I can pick any x between -9 and -7. And then actually I can keep the 7 because it says from 7 to 9. And then from 9 to 35. So to be honest, all I need to do, because there's no gap, there are no gaps.
Mm.
There are no gaps in this column. So all I care is if x has to be greater than, x is greater than or equal to -9. So that first part applies, and x has to be less than 35.
Oh, I see.
Now, if there were gaps in here, you couldn't necessarily do that, but there are no gaps
Mhm.
because it says less than 7 here, and then it says greater than or equal to 7. So there's no gap at the 7. It says less than 9, and then it says greater than or equal to 9. So there's no gap at the 9 either. So you're going from all the way from -9 to positive 35.
Okay,
So that's your answer right there.
gotcha.
Okay.
Yeah, that makes sense.
All right, next question.
Can we do 48?
48. For the functions f and g, find the requested composite function. Okay. So it's asking, so f dot g, probably should make that a little bit bigger. You can see a little bit better. So we're looking for f dot g. So how do we do this one?
So that means you put G in F, right?
That's right. We're going to put this fraction right here in for that x. So this one might be easier. Here's what I'm going to do. I'm going to paste just okay, so here's what we're doing. F of x equals 4 over that. Okay, I'm going to use my pencil and my finger here, so hopefully this will be legible. But basically, we're taking this and we're plugging it in right there. So this is going to give me 4 over 7 over 5x minus 4. Okay. Now all we have to do is simplify. How do we simplify?
Can the 4s cancel?
No.
No. You multiply by the inverse of 7 over 5
By the inverse? What do you mean by the inverse?
to try and get it out of the denominator. I'm not sure.
So we need a common denominator. So on the bottom, what's the common denominator?
Right?
Say that again.
5x, because on
Five. Right.
the 7 over 5x minus 4, that's basically 4 over 1. I mean, yeah.
Okay. So perfect. So on the top, I've still got my 4. On the bottom, I've got 7 over 5x. If I multiply this by 5x over 5x, I'm going to subtract what?
Isn't it 20x over 5x?
20x over 5x. Perfect. So now I've got 4 over 7 over, 7 minus 20x over 5x. Oh, this is so hard to write with your finger. Okay. And so now I can create this as a fraction as 4 over 1, right? And I can multiply by the reciprocal, which is 5x over 7 minus 20x. Okay. So my numerator becomes
20x.
20x. My denominator is
7 subtract 20x.
and that equals f dot g. F dot g. That's your answer right there. Okay. Does that make sense?
Yeah.
Okay. All right. What else do you have?
Can we do 38?
38. List the intercepts of this function. Okay. So how do we do that?
I wasn't even sure where to start on that one.
Oh, really? Okay, so here I'm going to do this. Okay, so we got a nice clean sheet here. And it says find the intercepts. So how do we find the intercepts normally, ignoring this problem for a minute?
By putting zeros in and solving.
So I'm going to set x equal to 0 and solve. And I'm going to set y equal to 0 and solve. Okay? So that's what we would normally do. Okay? Now, the problem is this is a composite function. So if I need to set it to x equals 0, can I do it? Can I set x equal to 0 on this first equation?
Yes.
Yes. Can I set x equal to 0 on the second equation?
No.
No, because my domain says x has to be greater than 1. So, so where x equals 0, then this applies. Okay. So if x equals 0, what does y equal?
Seven.
7.
Yeah, so y is going to equal 7. Okay, so this intercept here is going to be 0, 7. Okay. Now I need to set y equal to 0 and solve. Now the problem is, this is where probably drawing a graph will come in handy. So the first one you can do without a graph, but the second one, you're probably going to need a graph. Okay. So normally, if let's just take that first equation, those first two circles there. If y equals negative 5x plus 7, how would I graph that?
You start at positive 7, go up 7.
Positive 7. 1, 2, 3, 4, 5, 6, 7. My lines are getting bigger and bigger. Okay, so I'm going to start here up at 7, and I'm going to rise how many?
Negative 5.
I'm going to rise negative 5. So 1, 2, 3, 4, 5. I'm going to run 1, right?
Yeah.
So I'm going to have a straight line that's going to look like, I'm going to try very hard. It goes through there. Okay, so I'm going to have a line that goes like this. Actually, I didn't go through 1 very well. Let's try that again. I can't get it to go through both points at the same time. That's as close as I'm going to get. Okay. So now I need to look at my domain here. Domain has to be y is less than 1. So essentially, I get to erase this part of the graph because that's greater than 1. Okay. So I've got this here. Now let's go with the blue here. Let's pay attention to this piece here. If x is greater than or equal to 1, y equals that. So how would I draw that second equation? Let's ignore the domain for a minute. Y equals negative 7x minus 5. How would I draw that?
Start at negative 5.
So negative 5. So 1, 2, 3, 4. This is a different scale than I used above the axis. That's terrible, but anyway, it's good enough for what I'm trying to do. Okay, so I'm going to negative 5. I'm going to rise
7.
7. So 1, 2, 3, 4, 5, 6, 7, and I'm going to run
1.
1, okay? So now I'm here, okay? So essentially, if I draw the line here, it should go, actually, before I draw that line, it should go through this point right here, okay? So as I draw my line, oh, I can't get it to go through that point. It's really hard to get it. Anyway, it goes through that point, right? Now, maybe I can move it over a little bit. Oh, that's pretty close. Close enough for what I'm doing. Okay, so now I need to look at my domain. My domain says x has to be greater than or equal to 1. So at this point, I get to erase all of this, right? And I get to erase all of this too. Right up to there. Okay, so where does y equal 0?
At the 6. Wait, for y?
Yeah,
At the
where
point
does
we
y
ever,
equal?
sorry, at the point we already found.
Yeah, this point, it's kind of hard to see because I've erased it. This point right here, right?
Mm-hmm.
Now the problem is, can x equal 1?
Yes.
Well, so the point that's on the axis, which is what I need, that says x has to be less than 1.
Oh, we're doing that one. Okay.
Because at the point where x is greater than 1, at this point here, we know that y actually equals 2. So I put an open circle here, and actually it should be an open circle. This is actually should be a closed circle here. So where does y equal 0?
It doesn't reach it.
It doesn't reach it. So therefore, there is no y-intercept. So the only answer we have here in this case is this answer right here, 0, 7, because there's no y-intercept. Now, if these were flipped, if this said less than or equal to 1 and greater than, then this point here could have been an intercept. But since it's written the way it is, we've only got one intercept. Does that make sense?
Mm-hmm.
So looking back here, B is your answer. If we had flipped those, then B and, oh, actually, there's another answer that's not even there. None of those other ones matter. If we had flipped them, then 1, 0 would have also been an intercept. If we had flipped these inequality things here. If we'd put the equals on the top one instead of the bottom one. Okay. All right, excuse me. What else do you have?
Could we go to the second study guide?
Okay.
And on that one, could we do 30 and 31?
Okay. It's 30 and 31. Let's make this a little bigger. Okay, so 30, right? An equation of polynomial function with the given characteristics. So we need a function that crosses the x-axis at -1, 0, and 4. It lies between the x-axis. Here's what I'm going to do. I'm going to copy all this. And Okay, here we go. All right. So how do you do this?
So I started by making it so you had x plus 1 times x minus 1 or minus 4 just to.
Okay, so you're finding your factors.
Yeah.
So your factors are what again?
It was x plus 1 and then just
Plus 1.
and then just x and then x
X
minus 4.
minus 4. Okay, well done. So you got that just from this piece right here.
Mm-hmm.
Okay. So it's a polynomial function. It lies below the x-axis between -1 and 0 and above the x-axis between 0 and 4. Okay. So let's talk about, let's just graph what we have and see if we might be done, but we might have to throw a negative in here. So we'll have to see. So if we, I'm going to draw my axis here. Okay. So I have a 0 at -1. I have a 0 at 0, the origin, and I have a 0 at 4. 1, 2, 3, 4. Okay. Now, what's my power function at this point?
Well, if you multiply them together, that's what I did, and I got an x to the third.
Yeah, so you're going to have some sort of y equals x to the third, right?
Mm-hmm.
Okay. So now, with an x to the third, basically, it's going to, whoops, it's going to start low, it's going to end high, correct?
Mm-hmm.
Okay, now, we need to pay attention to this. Now, the way we've done this, let's just see. So I've got a multiplicity of 1 on all 3 of those factors, right?
Mm-hmm.
So the way it is right now, we're going to go through 1, 0, and 4. Okay, it's going to look like that. Now, is what we have right now. So it says it has to lie below the x-axis between -1 and 0. Is this below the x-axis?
No.
No. Okay. So that tells me I need to throw a negative on here in front, because that will create a mirror image here. Now let's make sure that it lies above the x-axis between 0 and 4. Once again, is this piece of the graph above the x-axis?
Mm-mm.
No. Okay. So basically, all I have to do is throw a negative on here, and to make it a function, I'm going to say equals f of x. Okay. So in this case, here, before I do that, so we could say that the function f of x equals -x times x plus 1 times x minus 4. Okay. And in this case, now it changes my whole orientation, so that's going to start high, go to 0, and then it's going to go like this. Okay, so this function is the red graph now.
Okay.
Okay, does that make sense?
Yeah, just when I did it and I multiplied it all out, I understood that you were supposed to put a negative in front of the x to the third, but I thought it also switched the sign of the x minus 4 from a negative x.
Oh, they actually, okay, so because let me just say this, if it asks for a function, I'm done. Since they gave you multiple choice, now you have to match their answer. But that's all you need for a function.
Okay.
Okay. Now if you FOIL that out, I'm gonna do the x plus 1 and the x minus 4. So that becomes x squared minus 3x minus 4. And now I need to multiply that by my negative x. whoops, negative x. Okay, so now when I multiply that through, that's going to give me negative x cubed minus 3x squared minus 4x.
I think it's gonna be plus 3x squared and plus 4x, right?
No, because when you FOIL out, when you FOIL out the x plus 1,
Because aren't you distributing in that negative x?
You're right. Never mind. You're correct. That should be a plus. Yep, you're right. I was not paying attention. Yep, that's correct.
So how did
No,
you?
actually, this. Wait. Let me make sure I'm following this right, because I'm not sure I followed it right. I did that in my head really fast. Okay, so this becomes x squared plus x minus 4x minus 4. So those two middle terms combine, and I'm going to be left with x squared minus 3x minus 4. Oh, yeah, that's what I had. And so, yeah, so actually this negative 4x needs to be a positive 4x. Okay.
So why did the singular x get the negative on there? That's just how.
You could put it anywhere you want, but if I stick it on the other two, then it's going to make it harder to FOIL.
Okay.
So that's why I just put it there. And I can say f of x equals, and now I've got a real function. So that's your answer right there. Okay. But once again, if it just asked for a function, that would have been perfectly fine to just leave it like that. That's a function.
Okay.
A
Thank you.
polynomial function. Okay. All right. What else? Did you want to do 31?
If there's not any other questions, but we can do something else if there is.
Anybody else want to do anything?
Let's do 31 because I'm still a little bit confused.
Okay, so do you remember what the intermediate value theorem is?
No.
Okay. So the intermediate value theorem says, here, I'm going to copy and paste this because I think it'll be easier. I don't need the rest of that. Okay, so the intermediate value theorem says that if you have opposite signs between 2 points, then there exists a 0 in between. Does that sound familiar?
Mm-hmm.
Not familiar? Okay.
It does.
Essentially what I want to do is I want to find f of -2, and I want to find f of -1. And I want to see if when I do that, if this one's positive and this one's negative, or if this one's positive and this one's positive and this one's negative, then I have a 0. But if they're both negative or they're both positive, then I don't know. I don't know if there's a 0 in between them.
Okay.
Okay. So f of -2 is going to be -6. Here, I'm going to just do this because this will calculate it for me. -6 times -2 to the 4th power plus 7 times -2 squared plus 5, okay? So if I type that in my calculator, I get negative 63, okay? So if f of negative 1 is positive, then I know there's a 0. And if it's negative, then I don't know, okay? So I'll do the same thing, equals negative 6 times negative 1 to the 4th power plus 7 times negative 1 squared plus 5, okay? All we're checking to see is this positive or negative?
Mm-hmm.
It's positive, okay? So therefore, is there a 0 in between them?
Yes.
So there exists at least one 0 in between. Okay. So that's what they did. Okay. Because these two signs are opposite.
Mm-hmm.
Okay. All right. Well, that was good. Well, do we have time for one more quick, easy one? Or are we out of time? What do you guys want to do?
I
No
think
opinion? Say it again.
I think I feel good about it.
Okay. So let me just say this. You guys in my 9 o'clock class asked completely different questions. Not one of them was the same. Although they did ask some that you asked yesterday. So if you want to really see what they studied, you might want to check out their video. But I will go ahead and I will post this video. And let's see, how many people do we got? We got 10 plus me, so that's 11. So y'all get a point today for coming to class. And I will post that, and I will post this video. And so tomorrow's review will be the other 3 reviews that we didn't. So if you want to check those out. And then tomorrow after class, I was toying with the idea, but I'm just going to do this. I will just post the exam. Would you guys like... See, the problem is, here's what you should do. If you guys want to be really prepared and if you want to know how good you're going to do, I can post the exam with or without answers. Maybe I should make that my poll question. Do you want to have the answers? Because the thing is, if I post it without the answers, and then if I post the answers in class, you will have a much better idea if you're going to, how well you're going to, your score on the final exam if I don't post the answers. Because if you have the answers, it's too easy to look.
I think it's a lot better to have the answers to at least check yourself.
Okay. Should we make that our poll question?
Yeah.
Okay. So that will be the poll question. I will still give everybody 1 point for showing up today. But that's going to be tomorrow's poll question is, do you want the answers or not before class?
You should post the test and then post the answers like separately, not in the same PDF. Have 2 separate PDFs. So if people want to have the answers, they can have them. And then if people don't want to have the answers, then they don't need them.
Well, that's a good, so now you got 3 options. Okay. So I'll make a survey out that's tomorrow that will be, you can have 3 options instead of just 2. Okay. All right. So thanks for coming. Keep studying hard and do awesome on the review.
Thank you.
Yep. We'll see you all tomorrow.
Thank you.
Mm-hmm.
Thank you.
Yep.